like this lesson was pretty much what you're expecting Tuesday to be. So
I know.
it sounds
For
like
some
you're on
reason,
board.
yeah, Tuesday, I was like ready for the math. I was like, come on, like we gotta divide something or whatever.
Mhm.
Nope, nope. Oh man.
Okay, group meeting quiz. Okay.
So question 3 is 1, right?
Oh, just 1 second. I just barely opened it.
Oh, okay, go ahead.
I'm just, yeah, I apologize if I'm like droopy. I'm like,
You're
something,
fine.
I'm just tired today. So I've got
Uh,
some caffeine with me and hopefully that'll wake me up. But I'm just
no
like this
worries.
entire day. I think it's because it's like, it's not super hot here. It's
Mhm.
like the 80s. But the thing is, it's humid for Utah. So not
Yeah.
like really humid, but humid for Utah because it's overcast and it looked like it might rain tonight. So
Hmm.
just kind of like the gray skies with kind of the warmish weather is just kind of like, oh, it's sleepy time.
I know it's like, oh, this is like perfect nap weather. I'm like,
Exactly.
I feel you. I feel you. The heat, like, especially coming out of the winter, like the heat really just like wears you out. I feel this. I feel you. So,
Yeah, well, Utah, it's been weird this year. I'm trying to think. Let's see. So we are in May. It actually snowed twice last month.
oh my heck.
Yeah, not once, but friggin' twice. And once it actually stuck around. Like the second time it snowed, it was gone by the afternoon. But
Yeah.
the first time it snowed, it was like the first week of April, and it stuck around until the next day. It was just like,
Oh,
what the heck?
get
Personally, I
out of
loved it. I
here.
was like, awesome.
Oh yeah.
Okay, so the total area under a normal distribution curve by definition is 1. Yes.
Yes. Sweet.
Okay, question 4. Under certain circumstances, a normal distribution curve can drop below the x-axis. True or false?
I feel like I read something about this, and so I know they.
Think about it conceptually. If the distribution curve drops below the x-axis, what does that mean? what are
That's like
your what are
non-existent
your y values if you're dropping below the x-axis?
frequency.
Yeah, the y values are always frequency. So if you get a y value that's below the axis, is that positive or negative?
Negative.
Can you have a negative frequency?
No.
So
No,
the
you
answer,
can't.
there you
So
go.
it's false.
Okay.
Yes, it's okay. No, is that
Question
true?
5. Yeah, that one's just a definition. A normal distribution curve by definition is symmetric.
Yeah. Okay, use the following image to answer the next 2 questions. So that would be number 6 would be C.
Score, yes, that's what I got.
This isn't too bad of a quiz so far. Just wait though. Just wait. I spoke too soon.
Okay, question 7. Which of the following represents a probability that a z-score will be greater than 1? Okay, what are you thinking?
Which of the following images represents the probability that the z-score? A.
Why are you thinking A?
Actually, I really don't know. I guessed.
Okay.
So area. Well, I guess it wasn't asking for that, but
Yeah. So scroll up to the image, and we can just look at it conceptually.
okay.
So do you got it?
Yeah.
Okay. So the distribution curve, it's not showing it, but right in the middle at 0 would be the median or mean, right?
Yes.
And
And
so
then
the z-score represents what again?
oh, Like the actual definition?
Yeah, what's a z-score?
Ooh, okay, wait, hold up. It is. Dang, I reviewed it in my head so I would know the answer to this question. It's like the mean minus the blah blah blah. Dang, where is it? Okay, it is. Oh, so the z-score for the data value tells how many standard deviations away from the mean. That's off. Yeah.
Exactly.
Sorry, that I was like, I kind of knew what it was, but so the standard deviation is 1. Or the z-score is 1.
Yeah, which would mean that in this case, the z-score is just the standard deviation.
Yeah.
But the z-score in general is simply the number of standard deviations you are away from the average.
Okay. Yeah. That's why the examples with the height and stuff and the reading.
Yeah.
Okay. Yep.
And it's always away from just the average, so you can have positive and negative z-scores. So it's always just how many standard deviations you are away.
Yeah.
And what are the three numbers for 1 standard deviation, 2, and 3? What percentages of the curve does that represent?
So 68, I think is it 68% is 1 standard deviation away from the mean on both sides.
Mm-hmm.
That makes sense.
Yeah.
And then I know the middle number is something, and which is 2 standard deviations on both sides, and then the 99.7 or 8 or something like that. So pretty much almost all of everybody's within 3 standard deviations.
Yeah.
Of the mean.
Like, yes. And the second, and 2 standard deviations is 95. So you can you can see that it's really how everything is clumped together around the average, because 1 standard deviation is going to encompass 68%.
Yeah.
So more than the majority of the population. But then 2 standard deviations, instead of going up 68%, it goes up like another almost 30%, And then another standard deviation on that, you only get another like 4%. So you can kind of see how it's distributed and how things just kind of get thin as you go away. So the extreme
so 68, 95, 99. Okay, that's what the numbers were.
Okay. Yeah. So question 7, which of the following represents the probability the z-score will be greater than 1?
So it'd be B.
Yes.
Okay.
Can you explain your thinking to me? Just make sure that we're on the same page.
So we just look at the z-score, and that's 1, which is the red line. And then anything greater than that would be the unshaded area, which is labeled as B.
Okay, perfect. Yeah. So basically, when we're looking at normal distribution curves like this, there's usually 3 things we're looking for.
Yeah.
It's either 1, everything beneath, like everything below a certain line, so like below a z-score. And that's going to tell us how much of the population falls below that percentile, Then in this case, the population that's above it, and then sometimes you're actually looking for the group of people between the 2 red lines. So, like you may get a question. There was one in the homework where it's asking, here's a z-score, here's a z-score. What percentiles do they fall under? And once you find out the percentiles, it's like, what percent of the population falls within those 2 z-scores? And so you figure out not the extremes, but how many people are scoring above like 28 on the ACT but below 31 on the ACT type
So
thing.
kind of finding the average. So if you wanted to find like the average or whatever, you would just highlight the middle section.
Yeah.
And that would give you the average, I guess.
Yeah, there is. I'm trying to, if I remember, there was one question on the quiz that wasn't quite that simple because if you play around with it, the red lines, so the z-scores, are always symmetrical. So in that case, you weren't able to use the applet because it was like a z-score of, I think, just off the top of my head, I think there's like a z-score of like positive 1.6 and a z-score of negative 0.5. And it's asking what percentage of the population falls between those ones. And since you can't stick one to 0.5 and then the other one to 1.6 at the same time, you had to do it separately.
Okay.
They'll probably pop up later in the quiz.
Yeah, I remember reading about how this applet thing won't do two different z-scores.
Yeah.
And then it kind of goes into how to do it if yeah. Cool.
Okay. Yeah, and it'll probably pop up later in this quiz.
Probably.
But it sounds like you understand how to use it, and you're right with question 7. And I'm just tired. This caffeine needs to kick in.
Drink the caffeine.
Okay, question 8.
Okay. Wouldn't it be 68?
Yeah. That one is just one of those questions filled with fluff, just meant to distract you.
Yeah.
These scores come first. Okay, question 9. You got that?
So I have to use the applet, right?
Mm-hmm.
And what portion of the z-scores will be between? Would it be 0.683?
Not sure about the 3. I'd have to double check that, but you're probably right. Because yeah, question 8 and 9 are just asking the same thing in 2 different ways.
Okay.
But did you catch that?
I haven't.
One was asking, according to the 68, 95, 99 rule, what percentage is going to fall within one standard deviation? Whereas question 9 is saying we have a z-score of -1, +1, which is one standard deviation. So it's just asking the same thing in just 2 different ways to make sure you understand it conceptually.
Okay, yeah. So it says do 3 decimal places.
Yeah. So is it 683?
Yeah. Well, it's 0.6827, so you just round it. So 0.683.
Okay, perfect. And so that makes sense. So question 8 and question 9 are the same thing, just different words, right?
Okay. Yeah, that makes sense.
Okay. Yeah, I think what this question was trying to do was kind of just nail down the idea that the z-score is the number of standard deviations. So you can think of a z-score.
So can I so in my head, should I separate z-scores and standard deviations, or are they pretty much the same thing?
A z-score of 1 is one standard deviation.
Okay, so if it's that, then I can combine them in my head. But if it's different, if the z-score is not 1, then I should separate them.
Depends on how the way that your mind is wired. The way I see it I see a z-score. So in my mind, I see z-score. I see z equal to x standard deviations. So standard deviation times x, and x is whatever you choose. So in that way, they're completely tied together. You know, the more standard deviations you have, the bigger your z-score is going to be, and vice versa. That's how I think of it.
Okay.
If the math just kind of messes you up, just think of a z-score as the number of standard deviations you have. Like, do you have one pizza, or do you have 2.5 pizzas, or so it could be easier to just tie them together in your mind or not.
Okay. Yeah. Okay. I might have to work on the homework and kind of see where what it leads to, I guess. Okay, so 10. So this is the same thing, the 90 or the 68, 90, 95 rule, right?
Yeah.
Okay, so it's 0.955.
That's what I got. So can you see that a z-score of 2 is 2 standard deviations? That kind of clicking?
Yeah, that makes, yeah. Okay. And then the next question will be 997.
Yeah. Okay, question 12.
Oh, the values match the 68, 95, 99 rule. Ooh, it's a long. Okay. Question 13.
Okay.
So what I subtract 0.65 from 0.07 and then what portion of the population? Okay, so
Okay, so first off, what's the z-score for question 13?
So the z-score. Okay, so how did you mean? The mean is 65, and then the standard deviation is 0.07. So the standard deviation is 0.07, and it wants to know less than 60, which is 0.05 away from the mean, which is 1.5-ish standard deviations away from the mean.
Oh, wait, say that again. So what's the equation for Z?
So the Z-score is your mean. Oh, sorry, your observation, which is 0.65, minus your mean. Oh, that is your mean. Gosh dang it. Okay, so it'd be 0.6 minus 0.65 divided by our standard deviation, which is 0.07.
Yes.
Okay. Okay, so let's try that. Okay, so our Z-score is going to be negative 0.714. Is that what you got?
That's what I got.
Okay.
And then what do we do after this once we have the Z-score?
Can we put it in the applet?
Exactly, yeah.
Okay, so we put it in the applet. 0.714. And then we want to know, what do we want to know? What portion of the population have less than 0.6?
So which portion of
We
the
highlighted
applet graph? Yeah, which part do we highlight if we're looking for people who are less than 0.6 grams?
The middle section.
Why the middle section?
So the Z-score on the right-hand side is 0.7, and we want to find something below that.
Say that again.
So the Z-score on the right-hand side is 0.7, and we want to find something 0.6, which is closer to 0. So that's like the middle section.
Okay, here's a question. What are the units for 0.6?
It's like protein something.
Grams
it's grams.
Protein.
It's grams.
Yeah. Grams of protein per kilogram per day. So that's the units of the 0.6. What are the units of the negative 0.714?
Same.
No. The negative 0.714 is a Z-score. Z-scores are unitless.
Oh, okay, yeah.
So you shouldn't be comparing them directly like that because they're two completely different things.
Two totally different things. Okay. So what portion of the population have a protein that is less than? So would I highlight just the left-hand side?
You're on the right track. Why?
It wants to know like less than. So if it was like greater than, it would be the right-hand side. If it was less than, then it'd be the left-hand side.
Okay, perfect. Yeah. The Z-score, the Z-score is going to give us the percentile, and then depending on whether we want to know who's above or below that percentile. In this case, we want to know who's below that percentile, so we look at the left part.
So just the left. Yes. So change the question a little bit. If it was saying Obviously, if it was saying what portion was greater than, we would do the right hand. But what would the term be for the middle section? It would just be like if we just needed to highlight the middle section, I guess.
If we just needed to highlight the middle section, they would have given us a two-part problem. So you see how we went down 0.05 grams per kilogram per day to get at 0.6. It would ask what portion of the population needs 0.6 grams of protein per kilogram today, between 0.6 and 0.7 grams of protein per kilogram per day.
Okay,
So,
that makes sense.
yeah, so if you're looking at the middle section, it would give you a range.
Okay. So the answer for this question would be 0.238.
Yes.
Okay.
Okay, and there's a long and a short way to solve this next problem.
Okay. So, what portion of the population have a protein? Okay, so we would just do we would highlight unshade the left hand section and just do the right section, the right hand section.
What do you mean just the right hand section?
Just the greater than section, I guess.
Which includes, we've got three sections. We've got left of the first red bar, in between the two red bars, and right of the last bar. So
That last one.
So which section would we highlight?
So the right hand side of the right hand bar.
And why are you thinking that?
Because it said greater than.
But what's it asking greater than what?
0.6.
And where does 0.6 fall along the curve?
Oh, is that the first red? Is that the left hand side, the right bar, the left right bar?
Yes.
Okay, so it would be the middle section inside the middle.
Oh, say that again?
So would we highlight two sections?
Yes.
Okay. So it'd be the middle section and then the right section.
Yes. What's the simpler way to solve this?
Could we minus our answer for 13 from 1?
Exactly. We know that the entire area under the curve is equal to 1. And when we already know the area of part of the curve, then all we have to do is minus 1. Minus that from 1, and that'll give us the remainder of the area under the curve.
Oh, look at that. Yeah, it works. That's cool. Okay. So it would be 0.762.
And that's what I got. Okay. And it looks like question 15 is what you were talking about a minute ago.
Okay. Portion of it. Okay, help me out. So it's saying 60 and 70, but how do I see that on this applet?
So the applet, you have to go to the equation for the z-score. Do you remember what's the equation for the z-score? You should just know it off the top of your head.
It's the observation minus the mean divided by the standard deviation.
Exactly. So in this case, if you're looking at it in question 13, how far away are we from the mean?
13. We're only 0.05 away from the mean.
Okay. And in question 14, how far away are we from the mean?
We are point 0.05 again.
Mm-hmm. So that means
Okay.
it's the same z-score, but instead this z-score is going to be positive rather than negative.
Get it.
So we don't even have to change the applet at all.
Oh, okay. Okay, so if we want to do less than 0.7, we would do um we would highlight the middle section and the left-hand section.
Perfect.
Yeah?
Yes.
Okay. So it'd be 0.762.
And that's what I got.
Awesome. Okay.
Okay. And question 16 is also what you asked a little while ago.
Okay. Okay, so we have to do two different calculations, right?
Not necessarily.
Okay.
Just
Um,
because the z-score is the same,
okay.
so we can just use the applet once.
Okay.
If the z-score, because you see how uh, the average is 0.65, we go down 0.05 and up
Oh,
0.05.
okay. Yeah.
If we'd gone down 0.05 and up 0.07, then we would have to do multiple calculations. But as is, we can just use what we already have because the z scores are the same. It's just they're the same, just
Yeah.
minus positive and negative of each other.
Yeah, it totally makes sense. Okay. Okay, so find the probability that random selection will have a protein. Okay, so am I just highlighting the middle section then?
Exactly.
Okay. Which is 0.525.
That's what I got. Okay, this next one, it's asking us to work same equation. So we're still dealing with the z-score and stuff. It's just asking us to do it in a different order than we've been doing it before. So it's giving us the percentile this time.
Mm-hmm.
If we're given the 35th percentile and we're asked, yeah, so find the 35th percentile, round your answer to 3 decimal places. What's the first thing we would do?
We would, I'm not sure.
Without without knowing calculus,
Uh-huh.
what is the only way we can find a percentile?
Looking at a graph.
And what graph do we have?
The applet?
Mm-hmm.
Okay. So are we like highlighting the left-hand section again?
We will eventually, but if we just highlight it, so highlight the left side section. What does it say?
The area is 0.2376.
So what percentile would that equate to?
Um, 25%?
Close. Why are you thinking 25?
Um, I guess that doesn't make sense. It would be mm, I don't know.
What does the area
Oh,
under?
okay, okay, wait. Oh, is this the rule? The 65-99 rule? Maybe?
It plays into that,
Okay.
but the thing is, it's like what, 65.8? This is asking specifically
Yeah.
35. So it'd give you, so you can't just use the rule. You have to
Okay.
take it a little step further. So when you highlight the left area and the area says 0.2376, what does that mean in
Oh, is that 23%?
exactly? Well, yeah, 23%. 23% of all the data lies on the left side. And so
Uh,
what does what
oh,
does the red line mean?
that's a standard deviation, right? Or this is z-score.
It is the z-score, but it's also telling us what?
It's one standard deviation away from the mean.
Is it? What's the z-score?
Or it's it's a 0.714 away from the mean.
Yes.
Yeah.
And that lets us know the percentile of the entire population. So right here, we're looking at the 23rd percentile, or I guess 24th percentile if you want to round up.
Mm-hmm.
So if we're talking about height, we would say that everybody on the left side is so 23.76% of the population is shorter than what this red line is indicating. So that's giving us the percentile. So if we want to change the percentile up to the 35th percentile, what do we do?
Can we highlight the middle section?
What would that do?
Ooh, that would bump it up a lot.
Yeah.
Okay. Can we add 0.71? Can we add the z-score to the area?
Do we have a z-score yet?
No. Yes.
What are we given?
Okay, so for this question, um we're just given 35th percentile.
Yes. And what would that correlate to the histogram we're looking on the applet?
Um the left-hand section plus a little bit of the motion.
Actually, yeah.
Oh, okay.
So, like you said, a little bit of the middle. How do we change it to get a little bit of the middle?
Do we just have to change the z-scores?
Close. You can change the z-scores, and that will give you
Oh,
a
can
little,
we
that will
change
give you
the area?
imprecise. Exactly.
Oh my goodness, I am so smart. Look at me. That took me like 10 minutes. Okay, so we just, oh,
So
that makes
you
it
could
so
change
easy.
So you could change the Z score, but in order to get 0.35 exactly, you're going to be off by a little bit just because the mouse is just so sensitive, you know? But if you
Yeah.
go to the area and type in 0.35, then that'll give you the exact Z score.
Mind blown. I was like, okay, like I know I have to move it, but I can't. How do I do them? I was like, duh, you just change the area.
Yeah, but no, you're
Oh my
completely
god.
right.
Okay.
We've changed it so that the z-score will show us the 35th percentile. We've
Yes.
highlighted the left area, which means that it is everything below the 35th percentile. So
Yes.
what's the next step that we do here?
So we just look at the z-score, and that will be our answer. Point three
That's the
eight.
next step.
Oh.
So
Um.
what is the z-score?
So the z-score is 0.3585. 0.385.
385. Okay. So what do we know now? We have got a z-score and what else?
So we know that 75% of the population, um, sorry, what am I saying? So we know that 35% of the population is below is 0.385 below the mean.
Yes. And so we're taking just kind of this relative curve where we're working with relative numbers and we're
Yeah.
trying to apply it to an actual population that they've given us. So we have a z-score. So we are looking for, what are we looking for? We are looking for the amount of proteins, the amount of protein that 35% of the population needs, or they need less than that. So up to. So that means we've got a percentile, which means we now have a z-score.
Mm-hmm.
What's the equation for z-score?
Oh, it's observation minus mean divided by standard deviation.
Okay. What do we have? We've got the z-score, and what else?
So we have the z-score and we have the standard deviation.
Mm-hmm. Which is 0.07. And what else do we have?
Um, I guess we have the observation too.
The observation is what it's asking for.
Okay.
So the observation is if you are at the 35th percentile for the normal population, how much protein would you need in your diet? So it's asking for the observation. So we've got the z-score.
Oh, so we just minus the mean. Sorry, we minus the z-score from the mean, and that gives you the answer.
You're close.
Oh,
What's the equation?
dang. Observation minus um mean divided by standard deviation.
So if you're going to solve for the observation, what does the equation become?
You times it,
Times what?
the mean and the standard deviation.
So
Oh, okay. So
so you might want to write out the equation on the paper and then solve for the observation x.
okay. X minus and the standard deviation is 0.385, right?
Yes.
Okay.
Oh wait. Say that again.
Is the standard deviation 0.385?
No, what is 0.385?
The z-score.
Yes.
Oh my gosh, what am I doing? Okay. 0.38.
And actually, you're correct. But what are you missing on the z-score?
The
Is
observation.
it left or right of the average?
It's left, so it's negative.
Exactly.
Oh,
So don't
okay.
forget to make it negative.
Okay. And the mean is 0.65. Okay. And the standard, so the standard deviation is 0.05.
What's the standard deviation?
Um, oh, yeah, it's 0.05,
Is it?
right?
Read.
Or I guess that's, I don't know.
Where are you getting 0.05 from?
I guess from our previous questions.
Exactly. Yeah. Yeah. You're getting.
I'm getting them confused.
Yeah. You're not. That's not the standard deviation. That is the observation that we got from the last two questions. Either 0.05 above or below the average.
Okay.
So right now we're looking for a new observation, which means that they had already given us the standard deviation. So do you remember what it is?
No.
Then scroll up to the information section of the question.
Okay. So am I looking at the... Oh my gosh, I'm going all the way back up here. Okay.
It's a really wordy question, but that's the thing is you have to figure out how to pull out the pertinent information when they just throw paragraphs at you.
Yeah, holy cow. Okay, so all right, so the standard deviation, oh, it's 0.07.
Exactly.
Gosh dang. Okay.
Okay, so we've got the standard deviation, our z-score, and the average. So what's the equation for the new observation?
So I'm solving for x, but so I have on the left-hand side of the equal sign is negative 0.385 equal to x minus 0.65 over 0.07.
So for right now, let's just work with symbols. So write it out just with symbols. So the symbols we have are x, mu, sigma, and
the little O.
Yeah.
Okay. Okay, yeah. So I got that. Equals
Okay.
4.
So then now rearrange it so that x is alone.
Okay, so I would do x equals z-score plus u. Oh. And then times it by, okay. Whew, my algebra is kind of rough. Okay, so it would be x equal to z-score plus times the standard deviation.
Okay, I lost you there for a second. So say that again.
Okay. So x equals z-score plus the mean times the standard deviation.
You are super close. You just got your orders of operation mixed up.
Dang. Okay. My algebra is a little rough right now. Okay, so would it be... Oh, okay.
So the first step, if you've got z is equal to...
So it would... Oh, gosh. Okay, so it'd be x equals standard deviation plus z-score. Oh my gosh, I don't even know anymore. I don't know, I'm getting confused.
Okay, so jumping back to the equation,
Okay.
I'm going to screen share real quick so I can just show you real quick.
Awesome. Let me make this bigger then.
Okay, so screen share. Okay, are you seeing my screen now?
Yes.
Okay, so we know that z is equal to the observation minus mu. So actually, I should change that. Z is equal to the observation x minus mu, which is the average, divided by sigma, which is the standard deviation. So
Yes.
far, we're on the same page?
Yes.
Okay. So the first thing that we want to do is we want to get rid of, because we're trying to dig down into x, but x is stuck within parentheses. So the very first thing that we want to do is get rid of sigma, which means we times both sides by sigma. So we got z times sigma is equal to x minus mu. And now we're just left with two variables on each side of the equation. We want x alone. So minus mu, we just add mu to both sides. So z times sigma plus mu is equal to x. Does that make sense?
Yes.
Did I go too fast for you?
No, you're good. That makes sense.
Is that coming back to you?
Yes.
Okay. So now we have the equation. Now it's just plug and chug to find out what our x or what our observation is for the grams needed in the grams of protein needed in someone's diet.
Okay. So we would plug in the numbers. So it would be negative 0.385 times 0.07 plus 0.65 equals x.
Exactly.
Okay. Okay, let's see here. So it will be 0.623.
Let me check what I got. 0.623. Yes, perfect.
Woo! Oh, that was difficult.
It's about as hard as it's going to get. And we've got another chance to do it again with question 18. So let's see if you remember how to do it. So starting off, we are given a percentile. What's the first thing we do?
Okay, so 80th percentile. So we go to the normal distribution thingy, the normal probability applet, and the area will be 0.80. And okay,
and we're looking for, what section are we looking for?
So we're looking for, let's see.
So area 1, 2, 3. Are we looking for 1, 1 and 2, 2 and 3, or just 3?
So we're gonna look for left and middle.
So areas 1 and 2.
Yes.
Okay. So everything below the 80th percentile.
Yes.
Okay, perfect. Okay.
And okay, so the z-score is, would we use the positive or the negative z-score?
Which one do you think?
The positive.
And why is that? You're completely on track. Think about it conceptually. You decided that we're looking for what 80% of the population needs for protein. So we're looking to the left side, right?
Yes.
If you took out that middle group so that you're just looking at the negative z-score, does that look like it's 80% of the curve?
No.
Okay.
Okay.
So just conceptually, you can kind of think about it that way. So you're looking at it and you look at the first third, then the middle, and then the very top of then the last third is whited out. And you can look at it and you're like, yeah, that looks about 80%.
Okay. Okay, that makes sense. Okay. So we would do, so the z-score is 0.842, and then you times it by the sigma, which is also the standard deviation, which is 0.07, plus the mu, which is the mean, which is we're using the same mean. So it'd be 0.65. Okay, which is 0.709.
Which is exactly what I got.
Yes, I love it when it makes sense. Awesome.
So is all this coming together in your mind?
Yeah, piece by piece, you know?
Okay. I'm actually thinking, I'm just seeing what the next topic is. So week 4, lesson 6. What are we looking at?
Hopefully it's nothing too crazy.
Distribution of sample means and the central limit theorem. So just scrolling through. We may need to spend just some more time on the next lesson on Tuesday.
Yeah, for sure.
But since you're on vacation and you're with your family, it sounds like this makes sense to you.
Yeah.
And then as you go over the stuff for next Tuesday, if it's just kind of like you're not understanding these building blocks, then on Tuesday we'll take a few steps back to make sure that we understand everything before moving on to the new stuff.
Okay, sounds good.
But yeah, you're with your family, so I don't want to eat up your family time.
It's fine. It's fine.
As long as you feel you've got enough to do the quiz before Saturday, then you're good, and then we can just jump back as far as we need to on Tuesday.
Okay, sounds good. I do think I get it. But yeah, we'll see how the new information builds on what I know now. There might be some gaps or something that we might need to fill in, but for now, I think I'm okay. And yeah, next week I'm like free to do whatever. So, okay, I really appreciate it. Let's see what we got on this quiz. I'm sure we got 100, but let's just check.
If I remember the quiz, this is actually pretty representative of the quiz. So if this stuff made sense to you, you should be able to do the quiz just fine. If you need just a quick reminder or explanation, shoot me a text. If you do just if you get home tomorrow and you're just like, oh my gosh, I totally spaced what we went over on Thursday, then we can Skype again on Saturday and I can walk you through it. So like if you're completely lost. But it sounds like you understand this stuff. And like I said, if you need a reminder, shoot me a text and I'll see if I can explain it in the text. If you're completely lost, I can help you out when you get back home.
Sweet. Thank you so much. And I will see you Tuesday if I don't get confused.
Yeah, it sounds like you understand it.
Yeah, hopefully.
Okay. Just kidding. Well, enjoy your last day with your brother.
Thank you. I appreciate that.
Do you have your nieces and nephews, or what do you got? Just nephews or a combination?
Oh my gosh. I have like 12 nieces and nephews. So, but they have 2 boys and 1 girl.
Okay.
So
try and grab all 3 in one big armful and just squeeze them super tight before you leave today.
I sure will. Okay. All right.
Then, yeah, I'll see you on Tuesday unless you have any questions.
Cool. See ya.
Okay. Later, Sarah.
Bye.